Okay, so part D says the method below will return the ith node. For example, if we call get node of 9 on the example heap, we will get the heap node containing x. So we are passing in the heap number. We are constructing a path of booleans, which is the false, true, telling us whether we're going to left or the right. And then using the method that we constructed in part C, we are going to take that path that we constructed and get the corresponding heap node. And so we already implemented follow path. We now need to implement construct path. So fill in the construct path method so that the get node I method above works correctly. You may use any method from the previous parts of this problem. So looking at our skeleton code, we have an empty linked list and we have a while loop, and at the end we return our list. So we know that we are going to need to be adding something to this list that's given to us because that's what we're returning at the end, and that should be the list of the falses and the trues. And so we know that we are given the node number that we want the path to. So we're kind of starting from the bottom, moving up. And so we know that the path, if we're starting at the bottom, will stop once we get to the root. And so our while loop, and our root has node number 0 always. And so our while loop can be while I is greater than 0, because we know that's where our path is going to stop at the top. We have to do some things inside of our while loop now. So while I is greater than 0, we would probably want to add which way we are going down our tree. So whether that's left or that's right, corresponding to false and true. So we would do list dot add and we can't add I because I is an integer and we need to be adding booleans. So however, we do have a method from part B called isWriteChild. So if we called isWriteChild on I, that would give us true if it's right and false if it's left, which we established in part C that false corresponds to left and true corresponds to right. So if we add isWriteChild, we can do, add first, because we want to add to the front of the list. So if we do isWriteChild called on I, then whenever we have a right child, we will be adding true to our list. Whenever we have a left child, we'll be adding false to our list. And so we'll be able to get that Boolean path that we wanted. And then the line underneath, we just have to update I. And in part B, we also created a method that gives us the parent of a current node. So if we assign I to be parent of I, we can move I up the tree until we hit the root. And then we return our final list.